There we go. Awesome. All right. Welcome to class. Here's the warm up for today. So go ahead and take a few minutes, see if you can write out the code for this problem. Using find index probably won't work. You can do it however you would like. But because you don't know the index of the element you're looking for, you need to figure out which I suppose it might be kind of confusing. This 3 indicates the index of this number, not the number itself. Maybe another way to see this is if I just change these to 5s, then it's clear that it's not the same as the value. Go ahead, Herman.
When you mention sequence in this problem, does that mean that the number itself has to appear consecutively without any breaks with a different number in between?
Correct. So here's 1, here's 2, here's 3. And if we were to add on here, that would be a separate sequence of 5s.
Gotcha.
Give you about 2, maybe 3 more minutes. Okay, let's do it. I'll say one more time, welcome everybody. A couple people just came in. There's lots of ways to solve this problem. I'm gonna jump in by showing how to solve it with 2 pointers, and then I think I'll look at anybody's code who would like that. Let me just comment this out real quick. And let's take this example here and bring it down here. So 2 pointers is exactly what it sounds like. It's 2 pointers. Typically one is sort of lagging and one is leading. So in the case here, this is, again, not the only way we can solve this problem, but it's a nice simple problem to introduce us to the concept of having 2 pointers. So we've got this pointer, which is always going to hang back, and this pointer, which is going to run ahead. In this problem, we say, all right, while the 2 pointers are pointing at the same number, go ahead and move this one forward. So we check and we say, okay, same, move up. Same between lagging pointer and leading pointer, move up. Okay, now we have different 1 and 5. If they're different, we want to do some logic here. So I'm just going to write a little bit of, we'll call this pseudo-ish code, pseudo code. If different, what do we want to do? Well, we want to find the distance between them because we care about the run of these numbers or how far they are. So first, let's say find distance between lagging and leading pointers. Give us a little more space here. Then check if this is max distance. We'll set a variable for max in just a second. If so, update max and update index. And finally, when we're done with all of that, we'll return the index. Let me break that down a bit more. Is lagging and leading similar to previous and current? Maybe, depends on how you use previous and current. Oftentimes previous and current means like the last thing we looked at and the current thing we're looking at. And here we see that's not exactly right because a lagging one could literally be 100 elements behind us, or it could be one element behind us. We don't know. We give room for it to be as far as it needs to be. Whereas usually when we're using variables like previous and current, we mean what's the previous value we saw and what's the current value that we're looking at. Whereas here we're saying, what's the last time we saw a new number for the first time and what's the number that we're seeing now? Anyhow, I suppose I'll become more clear as we go. So if we were to say here, we'll start with a max equals 0. And let's give this a better name. We'll say max sequence length. And then we'll say index equals, we might say null. It depends a little bit if we can have an empty array here or not, but let's just say null for now. And now we start our 2 pointers. We can start them on the same number or one number and then the next number. It's really up to us. I'm going to start them like this at 2 separate numbers. So are they the same? Yep, they're the same, move up. Are they the same? Same, move up. Are they the same? Nope, no longer the same. 5 is not the same as 1. So what do? We find the distance. So we say, okay, this one here is at 0, 1, 2, 3. And we subtract from that the position of our lagging one. That's at 0. We see that that equals 3. 3 indeed is the number of ones here. So we can just eyeball that and say, yep, that is correct. Is 3 bigger than our max sequence length? Yes, it is. So we're going to update that. And then we're going to update index to the lagging index there, which would be 0. And with that, we now move our lagging pointer up all the way to where our leading pointer is, and we can keep going. So are they the same? Yep. Same. Yep. Same again. Yes. Moving up one more time. Okay, now we see different. Now we're ready to repeat this process, but of course we're going to plug in new numbers here. So our leading pointer is at 0, 1, 2, 3, 4, 5, 6, 7, index 7. Put that here. And our lagging is at 0, 1, 2, 3. Great, move that there. 7 minus 3 equals 4. 4 is bigger than our max sequence length, so let's update that. And because it's bigger, we also want to update the index. So we'll set the index to exactly where our lagging pointer is, put that to 3. And now we jump this all the way up here. And we do the same thing. We see 4 and 4, yep. Okay, 5 is different than 4, so we process it again. This is now at 9. This is at 7. Yeah. There we go. 9 minus 7 is 2. However, 2 does not beat our current max, so we don't need to do anything except for move this up here. And now we'll compare. Now, one little gotcha here with this 2-pointer pattern is we want to take this leading pointer all the way off the array. So it's looking at undefined. Undefined is not equal to 5. And so again, we'll take this number here, which is 10, 11, 12, I believe. Yes. Minus 9 equals 3. And we see, yeah, that's correct. There are 3 5s here. but it doesn't beat this. Therefore, we're ready to just return. We're done with the whole thing. We're ready to return an index of 3. And that is the correct answer here. I'm going to start going through that code, but let me pause there. Does anyone have questions about that? Okay, let's reset here with our little pointers. And let's look at how to write the code for this. Let me just comment all of this out. And here we say function find index of longest sequence of same num. Seems like an okay name. Here's our array of, I'll put here nums, even better. Okay, so to get started, let's grab these variables right here. So I'll say max sequence length equals 0. And then let index equals, I think we'll just set this to 0 as well. Again, if we were in an interview, I would ask at this point, can we have an empty array? And if we have an empty array, of course, that means we have no sequence whatsoever, not even one number. And in that case, what should we return? Should we return -1 or null or something like that? If we were going to return -1, then we would just set that here and be ready to do that, or we can do null again. I'm going to look at the interviewer or the problem description to understand better what to do there. With that, now let's set our lagging pointer. So I'm just going to call it lagging pointer for the sake of this example. And we're going to set that to 0. And then let's set our leading pointer. Now, we can set a leading pointer, but oftentimes the way to set your leading pointer is just use I like you would in a regular loop. So here we'll say let I equals 1. I is less than nums dot length, but we need less than or equal to, goes off the edge. And then I plus plus. Great. Now we start to get our logic down. We have two things. If same, do something else, they're different, do something else. Now, if same means if nums at lagging pointer is equal to nums at leading pointer, what do we want to do? Whole lot of nothing. Do nothing. Or another way we can say this is continue, if we want to put it in code language. Really, we're just going to get rid of this block in just a second since we don't need it, and we'll put our condition over here. Otherwise, we have quite a lot to do. And that is calculate distance if distance is greater than max, set max to distance, set index to lagging pointer, and move lagging pointer to I. Okay. Down here, we need to finally return index. All right. Let's finish out here then. Calculating distance, const. We can use const here because we're not going to change anything. Distance equals our leading pointer. I put leading pointer here. This is just needs to be I minus lagging pointer. Let's log that out. There we go. All right, pretty simple from here. If distance is greater than max, max equals distance, index equals lagging pointer. And the order is very particular here, right? We can't, if we set index after we've moved a lagging pointer up, that will not work. Lagging pointer equals I. Okay, I think we've done it. I've left a console log for the distance here so we can check that. Do nothing. This is a good indication that our logic is redundant here, so we'll have to fix that. Let's run through the code with our example. And then we'll run it. Okay, so here's our example. I get this close as possible. Let's see if I can just make that. There we go. Okay. Our max sequence length 0. Our index is set to -1, just in case we have no elements here whatsoever. Our lagging pointer set to 0. We'll put that right there. And here we start our loop. We'll put this one as I. So this equals I. I starts at 1. So here we have 1 and 1. Are they the same? Yes. Therefore, just continue. That's going to go over to here, and I is going to move up by 1. Okay, now it's going to happen again. Now they're not the same. So we come down here into else. Distance is equal to I3. Put this here. 3 minus lagging, which is at 0. And 3 minus 0 equals 3. Console log distance, we should see 3 here. Then we say if distance is greater than max, oh, problem here, right? Max sequence length, max sequence length, max sequence length, good, better. Okay, distance, yep, this is true. And here we say then max sequence length should be set to 3, index should be set to 0, and this should be set to 3. That brings us back again. This comes up to 3, this moves up, and it's going to move up, move up, move up until it gets to here. And now we're right back into this condition again, into our else condition. Now we have, I forget what it was, 7 minus 3, I believe. Yep, equals 4. And so on and so forth. We should see 4 console logged here. This should be true again, and this should update. So let's start giving it a run. Let me pause also for questions, or at least while I set this up, go ahead and ask any questions. I got my eyes on the chat too. Let me see if we're clean here. Yep, okay. So here's our array, passing that array into the function here. Give that a run. Okay, something doesn't look right. I've got my distance here. I see 3 and 4, so that does look good. But I don't see the answer I expect here on the final return of the index. Let's get rid of this for a second and see what we have. Yeah, that's no good. 7. Is that right? No. 0, 1, 2, 3, 4, 5, 6, 7. That can't be good. Distance equals I minus lagging pointer equals I plus plus. Does anybody see the bug? If you do, you can just tell me. Gordon, you made a big mistake right here. Go ahead, Herman.
I don't see a bug, but when I use like a variation of your code for my example, it works as intended. So maybe it's just a comparison or something that we're not seeing.
Meaning you have code very similar to mine and it's working.
Yeah, so let me just drop in the chat. Like that's what I have, and it returns the correct answer. Because I think the only significant difference that, well, I guess not really significant, was my comparison for number or line 21. But I don't think that's even an issue.
If nums at lagging pointer equals this, do this, and you have
Yeah, because it's basically almost like line for line
Just the
what you
opposite,
have.
right? Okay. Well, I don't know. Let's debug it. Let's figure it out. I don't know what's going on here. ISS nums.length. Nums is there. Yeah, looks good. Index is here. Lagging pointer, sure. So let's check. Let's bring back this console log for distance. What's happening here? Seems like somehow the lagging pointer isn't getting moved up. So looking at this, we have 3, yes. And then we have 4, yeah. And then we have 2, correct. Then we have 3, yes. Then we have 4 and we have 5. What's up with that? How can that be happening?
Do we have like any other console logs here that haven't been commented out?
4 and 5, and then 5 is giving us this. I don't think so.
Do we also have to consider the fact that we're undefined at some point?
At the end?
Yeah.
Yeah, that should be this one right here. I mean, that should be this here. Let's go to nums at I as well. We see that. So looking at 5, it sees a length of 3. Good. Looking at 4, it sees a length of 4. Fine. Looking at 5, it sees a length of 2. Yes. 5 looks at the length of 2. And then looking at 5, it sees a length of 3. And then 5, it sees a length of 4. Something happens here when I get to this 5. I see a length of 2. Then I should move this up. Why does that not work? Max sequence length, distance, index equals lagging pointer equals I. It's like this doesn't move up at the end.
Can you
Undefined
off-
5.
sorry, can you take off the equal sign just on line 20?
Great. I think that introduces a new bug though. I think if we do this now, it won't work, but maybe not. I would like to be wrong about this. No, that's good. 0, 1, 2, 3, 4, 5, 6, 7. Yeah, it is a bug. See, now the answer should be 9 because we have all these 5s at the end here. And it's hitting this 4 instead. If I put the equal sign back. Still a problem? Wow, that's kind of confounding and frustrating.
Can you do something
mean-
outside of your else block and like
I can, but then it becomes so it becomes kind of redundant. Like I can check down here at the end. I just don't like doing that. I can say something like, if they're different down here, then update it, but we shouldn't need to do that. Let's try and refactor this a little bit. Let's get rid of this and this. And let's say if nums at I is not equal to nums at lagging pointer, excuse me, then we will do this. Calculate the distance. Yeah, let's see if that's any better. Still not good. 0, 1, 2, 3, 4, 5, 6, 7. Still happening there. Okay, 0, 1, 2, 3. So that's good. We're getting that correctly. But if the last sequence is the longest, we have an error. Now that's 5. That I'm getting here. Okay. Let's figure it out. I is 1, I is less than or equal to nums dot length. Undefined 2. Nope. 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 Okay, check it again. 5, 3, that's good. Looking at 4, we see a length of 4, that's good. Looking at 5, we see a length of 2, that's good. Then 5, 3, 5, 4, 5, 5. Looking at 5, we see a length of 2, then we should move up. Then it should be same, 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 different. And we should get this one here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Why then is it not moving up? Lagging pointer equals I. So let's do, try and see where our lagging pointer is. 7, 7, 7. Okay. Goes up to 3. That's good. Goes up to 7. 3, 4, 5, 6, 7. That's good. And this one's up here. Why doesn't it move up here? 7. If this is not equal to this, yeah. Find the distance. Yep. Let's get rid of this now. Oh, here's the bug. The bug is lagging pointer always needs to move up. My bad. This one here. Yep. Sorry about that. This needs to go here. Lagging pointer needs to move up whether or not we found a new max. Just the fact that we saw different numbers means that it needs to move up. Anyway, just got to stick with those things when you got bugs like that. And now we should see 9. There it is. Very good. And if we shorten this back down to 3, for example, we should see 3 again. There. Okay. Does that make sense? So here is our logic that says, if we found a new max distance, then we want to update these two variables. But whether or not it's a new max distance, we still want to move our lagging pointer up from where it was. So I had put this wrongly inside of this if statement, and it needs to be out here. We've also gotten rid of our if else, and we've avoided the kind of thing down here where we say, you know, we want to do one final check. I don't want to have to do one final check down here and run extra logic. I want it all to happen inside of my loop. And as long as I use less than or equal to, that will handle that nicely. A very easy gotcha here, though, is don't do that and then have the longest sequence be this one. And now what will happen? We miss it. Even though our answer here should be 9, it's giving us this one here. So to fix that, we need to make sure that our leading pointer goes off the edge of the array. We'll run that again, and now we'll see we get 9. Great. And again, that's without doing any kind of extra logic outside of this loop here. Good. It's always more confusing when the teacher makes mistakes, but hopefully at least you can see, you just stick with it and figure it out. Let's pause. Who has questions about this? Okay, let's do another exercise then. find the length of the longest sequence. All right, so 4, 5, 6, 1, 2, 3, 4, 5, 7, 8, 9. Okay, so we have one sequence here, 4, 5, 6, that has a length of 3. Then we have 1, 2, 3, 4, 5, that has a length of 5. So that's bigger than 3. And then we have 7, 8, 9, another one of 3. So 5 wins. We want to return 5 here. And in this case, we're not returning the starting index, we're returning the actual length of the longest subsequence. So take a minute and write the code for that. I'll write another example here. Can use the exact same pattern that we just used. Okay, give me one more minute. All right, let's go. Anybody have code? Throw it in the chat if you've got code. Okay, nice. Copy. Got mine here, but I'm gonna go with yours. Okay, find longest sequence nums, max sequence length, great. Lagging pointer, great. No need for an index variable here, right? Given the slightly different prompt. Then we've got I is equal to 1. This is our leading pointer here. I is less than nums.length, I plus plus, and less than or equal to, sorry, nice job. If they're not equal, this is what we care about. Although here, it's not that we care if they're not equal, right? We have to look at if they're ascending by 1. So I think we have to change this a bit. Could be wrong. Distance is this. Yep. Distance is greater. Yep. 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 I think all good except for the fact that we're not looking for the ascending order here. Let's give this a try. Let's say, okay, console.log this with nums. Let's take one of these here. There we go. And let's get rid of this. And I think I named that array. Yeah, good, good, good. All right, let's run that. Okay, I see 1. That's not right. Let's see what is going on here. So I believe our problem comes down to this. Last time what we cared about was, is the lagging pointer pointing at something different than the leading pointer? However, now what we care about is the leading pointer not exactly 1 bigger than the number behind it, and not at the lagging pointer per se. So if we say, here's our lagging pointer, here's our leading pointer, in other words, this is I, like that. Where do we, in the one case we just continue, and in another case we stop. So we continue if this number is exactly 1 greater than this number. So, okay, we move up. Now we care that this number is exactly 1 greater than the number before it. So if the leading pointer is exactly the number before it plus 1, then just continue. Anything else, then we want to stop. So in this condition here, let's say if this is not equal to nums at I plus 1, then we want to do these things. Let's see if that alone might fix up our logic here. We still see a 1. All right, let's check it out. So first let's do console.log nums at I. So we expect this to console log anytime we see a number that's a new sequence, 1 and then 7 and then undefined. Oh, I see all kinds of stuff here. So what is going on? If our current num is not equal to the previous num plus 1, do this thing here. What did I mess up? How can this be so bad? I see nums at I minus 1 plus 1. That's why I need to look back 1 number. Otherwise, they're never going to be equal to each other. Okay, 1, 7, 5. Our longest one is 5 here, so that does look correct. And 1, 7, 1, 7, and undefined are exactly where it should be calculating the new longest one. I think we're good there. Let's go ahead and run that again. Great. There's 5. That's our longest sequence right there. 1, 2, 3, 4, 5. Let's do a little bit more thorough testing here. So down here, let's come along and say, what if we had an empty array? If that was the case, we would expect this to equal 0. Let's see if that returns true. Great, we see that that's true. That's our base case. From there, let's do a little more testing. What if we had one number and only one number? Now we would expect to have 1 be our longest sequence. Great, we see that that is also true. Okay, what if we had 2 numbers in a row? So 3 and 4. Now we would expect to get 2 here. Wonderful. Okay, what if we had one sequence followed by a longer sequence? It could be like this. 3, 4 is a sequence of 2, and then 1, 2, 3 creates a sequence of 3. So we'll do that there. Great. Now, what if we had a longer sequence like 3, 4, 5, 6, followed by a shorter sequence? We expect now to get 4 here, since this sequence right here is 4. Run that. And if you haven't seen me do this before, I'm just making simple tests here, right? I'm saying this thing here should return 0. And therefore, if we evaluate this and it is 0, then 0 should be equal to 0. And we should get true here. And we know we're passing our test if we just see true, 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 true. If we mess up anything, we'll hear about it. Yeah, great. I think we're pretty much done here. Let's go with the 2 examples we had to make sure we're all good. So this should be 5. I'm just going to throw this in right here. And that. Great. We've got one more, which is this. And that's this should be equal to this. And we'll go with that. And there we go. Awesome. Nice job. Thank you, Zane. We just had to make a bit of a small change there. Not a big deal. Okay. Let me pause again for questions, and then we're going to move on to some leak code using 2.0.